Hello friends, in today's lecture we are going to talk about RISC and CISC. Hello friends, we are going to talk about RISC and CISC, and we are just going to compare these two. Let's first talk about CISC. CISC is a computer architecture, which is its full form is complex instruction set computer. Okay, so why this CISC architecture was introduced? Because its main aim was to simplify the compilers and to improve the performance. The CISC instructions. CISC means complex instruction set computer. Okay, don't forget that. And the RISC means reduced instruction set computer. So complex means um, more more number of operations will be specified by one instruction. Okay, here you can see that machine instructions resemble HLL statements. It's the CISC's main aim was to simplify the compiler. Okay, so that it doesn't have to do. Remember, when you are executing any program, what happens is all the instructions in your program, in the program which is written in high level language, it will be first converted into machine level language. Remember that. And we are talking about these machine level instructions. Okay, how these machine level instructions can be designed so that the performance of your computer can be improved. Okay, so for these machine level instructions, we are talking about complex instructions. Complex instructions means these will be these instructions will be specifying more operations in single instruction. Okay, that's why the decoding is going to be a little bit harder. Okay, so let's first see what are the advantages of CISC. So the first advantage will be the program will be shorter, as more number of operations will be can be fit into one instruction. The CISC architecture yield shorter programs, and as the programs are shorter, the execution will also be faster. Okay, as the number of instructions are less, the number of fetches is going to be less instruction fetches, takes less amount of memory. If you are going to use paging means, as we have talked about in last lecture, in cache, you are getting if you are getting the instruction from cache memory, then there will be less page faults, right? As your program is smaller, you have to fetch less number of instructions, and it will require less amount of memory. Now let's discuss some of the disadvantages. As the instructions are complex, the opcodes will be longer in case of CISC. And remember that the entire control unit must be made more complex, or the microprogram control store must be made larger to accommodate a richer instruction set. See, the microprogrammed control unit will be the designing in case of CISC. The designing of microprogrammed control unit will be very much complex, as the instructions are complex. So, and last one is either restrict interrupts to instruction boundaries, or must define specific interruptible points and implement mechanisms for restarting an instruction. see what this means is, as the instruction is complicated, as the instruction is complex, it's going to take more amount of time for that instruction to be executed. Okay, now when an interrupt occurs, what are you going to do? You are going to either, you can save the status of current instruction and handle the interrupt occurred, or you can ask the interrupt to wait and first complete the instruction execution. Okay, and then you can handle the occurred interrupt. Okay, so there are these two options. That so first means uh, the second way, I mean, you are going to first execute the instruction. That means restrict interrupts to instruction boundaries. Or first way, must define specific interruptible points and implement mechanisms for restarting an instruction. Okay, I hope that is clear. I mean, you can also specify some points where you can check for interrupts while the instruction is getting executed, and you can also specify some kind of mechanism like storing the instruction status and then resuming the instruction after the interrupt is handled, interrupt is processed. Okay, so this was all about CISC. Okay, CISC means complex instruction set computer. Now let's talk about RISC. RISC means reduced instruction set architecture. So its basic characteristics are see, one instruction per cycle. Okay. Next characteristic is register to register operations. Then simple addressing modes, simple instruction formats. Now let's talk about these one by one. Let's first see what do you mean by a cycle in case of reduced instruction set architecture. One cycle means the time required for the processor to fetch two operands, perform an ALU operation, and store the result back into the memory. That time, that time will be considered as one cycle. And as you can see, the instruction per cycle there will be only one instruction. That means these instructions will be simpler. As the instructions are simple, the length of program will be increased, and it's a little bit opposite of your CISC architecture. Next point is register to register operations. Remember, when we are talking about reduced instruction set computer, it will perform most operations by using registers, and register optimization is also encouraged by RISC architecture, and that's why it will be a little bit faster, as it doesn't have to go to memory and perform the load and store operations. Most operations, I'm talking about most operations, not all the operations are registered to register, but most operations are registered to register. Next point is simple addressing modes. As you are going to specify the registers, most as we have just talked about, most of the operands, most of the quantities required for execution will be stored in the registers, in the processor's registers. The only the computer only have to specify the registers from which the operand should be processed. Okay, that's why the addressing modes are going to be simpler. And last one is the simple instruction formats. See, in case of reduced instruction set architecture, the instruction format is simple, and the length of instruction is fixed. Okay, so when you fetch the instruction, the whole instruction will be fetched, and The opcodes again are going to be a little bit smaller because the instruction, as the instruction set is reduced, the opcode is going to be smaller and it will require less amount of time for your processor to decode these instructions, the reduced instructions set architecture. And also remember one more thing, it will be very much complicated to implement pipelining in CISC, but the pipelining can be implemented easily in RISC. Okay, so let's now talk about uh, RISC as compared to CISC. So first is simple instructions, as we have just talked about it. Simple instructions, one machine instruction per machine cycle. And this is one of the important points. There is little or no need for microcode. It can be hardwired. He adds the instruction set is simple. The control unit, you can also use hardwired control unit. You don't have to use a micro-programmed control unit because the instruction set is simpler. This one is also, we have talked about register to register transfer, and last one is simple control unit. As the instructions are simple, the control unit is also going to be simple. And this is our last slide for today. We are going to talk about RISC. We are going to continue talking about RISC. As in RISC, registers are going to be used. The register addressing is simple, and instruction format is also going to be simple. With fixed fields, opcode decoding and register operand accessing can occur simultaneously. Opcode decoding and register operand accessing can occur simultaneously, so that the speed of your execution can be increased. Instruction fetching is optimized because word length units are fetched. That means one word will be fetched. In case of RISC, one word will be fetched from your memory into your processor. Okay, so that's why, and in most cases, the word length will be equal to the instruction length, and in one fetch only you can get the whole instruction. Next point is more effective optimizing compilers can be developed with more primitive instructions. As the instructions are easier, so what we are talking about is the instructions will be simpler and primitive instructions. That's why the compiler will be more optimized and more effective. And also, I have just told you that instruction pipelining technique can be applied much more effectively with a reduced instruction set. And this RISC architecture is more responsive to interrupts. So in case of RISC instruction, if RISC instruction is getting executed and an interrupt occur, then you can just stop the instruction execution and first handle the interrupt and come back to your current instruction execution, and that will be easier in case of RISC. Okay, so these are the main different points about RISC and CISC. The current computers, the computers which are being used in today's life, they actually don't use complete RISC architecture or complete CISC architecture, as both of them have few important advantages. That's why. So some of CISC architectures today make use of some RISC features, and some of RISC computers today make use of CISC features. Okay, so all the today's computers are combined with both of these, the features of both of these instruction set computers. Okay. We'll stop here for today, and we'll continue our next point in our next lecture. Thank you.